Tonight, what we're going to be talking about is percent composition. And when we talk about percent composition, we are talking about the percent by mass that each element contributes to a compound. So what percentage is carbon by mass in CO2? Okay, so the formula that we're going to be using is the percent composition over 100 equals the grams of that individual element over the total molar mass. And by the grams of the individual element, we're including all of the grams that particular element contributes. So if there's two oxygens in a particular element, it would be the total mass, so it would be 2 times 16. Okay, it just wouldn't be 16. So there are three basic types of percent composition formulas that I'll ask you, or calculations that I'll ask you to do. The first one is just a straight out, hey, what is the percent composition of C3H8? And I'm going to change this. I'm just going to say percent composition. When I say percent composition, I'm talking about both carbon and hydrogen. I'm going to do, for this example, just carbon. Okay, so we're going to just do the percent composition of carbon in this. And so using this formula, I am trying to figure out the percent over 100, and that is equal to the grams of that individual element. Well, that individual element for the percentage of carbon would be 3, because I have 3 carbons. Each is contributing 12.0 grams over the total mass of molar mass of that compound. So that would be 3 times 12, plus we've also got the contribution by hydrogen, so that'd be 8 times 1.0. Okay, when I solve this, I get 36 over 44. Not solve, I guess simplify. All right, so now I'm ready to solve for this percent. So I'm going to do percent times 44 equals 36 times 100. I'm just cross multiplying. You absolutely do not need to show this work. And when I solve this, I get my percent is equal to 81.8%. For percent composition, I'm going to have you round to the nearest tenth. We're not going to worry about sig figs in this case. We're just going to worry about rounding to the nearest tenth. So we get 81.8% of C3H8 comes from the carbon molecule or atom. All right. Example 2. Example 2 is when I give you more specific types of numbers. Instead of saying, hey, here's my formula, what percentage is magnesium or which percentage is oxygen, I give you literal amounts. So I know that I have 8.2 grams of magnesium and I have 5.4 grams of oxygen, okay? And when I ask for the percent composition of this compound, for this one I'm going to do both of them just because that's what I'm just going to do it, okay? So magnesium, for magnesium, you're going to take the percent over 100. Okay, I'm still trying to find the percent, so I'm going to leave that blank. And that equals the grams of that individual element. So in this case, I know literally my grams is 8.2. Okay, grams. I don't know the molar mass, but instead what you're going to think of it as is the total mass. So we're going to go with 8.2 plus 5.4. Okay, because that's my total contribution of all my masses of my individual substances. So when I simplify this, I get 8.2 over 13.6, and that still equals my percent over 100. So when I multiply that out, I get 60.3%. Okay. One way you can solve then for the oxygen is you can do the exact same format. So you're going to take percent over 100. Instead of 8.2 though, we're going to have 5.4 grams because that's the contribution by oxygen over my 8.2 plus 5.4. And that equals 8.2 over 13.6. I'm sorry, it equals 5.4 over 13.6. And when I solve that, I get 39.7%. Okay, so you can still do it that format, but if there are only two elements, I either have magnesium or oxygen, if I know that 60% comes from magnesium, then all I have to do to figure out oxygen, because total they're going to equal 100, is take 100 minus 60.3%, and I get that 39.7. So you don't actually need to show this work as long as you show that work. Okay, you can choose either or for the second element or the last element. So for example, if there was Mg, C, and O, and you already know Mg's and C's percent, then all you have to do is add those up and subtract that from 100 to get your O percent. The hardest one by far and away is this last example. And this one is where you have to actually calculate the exact mass of carbon that's found in a specific amount of a particular substance. And what I'm going to show you is a series of like equations. So if I use this formula down here, okay, I know that my percent, okay, is over 100 is equal to my mass for the grams of the individual element, which would for carbon would be 3 times 12.0, all over my 3 times 12.0 plus 8 times 1.0, okay? But that is percentage wise, okay? If I solve for this, I would be getting my percent. I know that in 82 grams, it's going to be the same, carbon's going to contribute the same percentage as if I had a mole. The mole is down here. That's the percentage, or that's the mass in a mole of C3H8. But the percentage is going to be the same whether it's 82 grams, a mole of it, 97 grams, a billion grams. Okay, it's going to be the exact same percent that carbon can contribute. So I know that I can set this equal to X amount of grams of carbon over 82 grams of C3H8. Okay, I know that because the percentages are always going to be the same. Now, if I know that, I can solve just for this equation and ignore the percent, because in reality, the proportion is the same on the top as on the bottom for all three of these equations. The relationship is. So now I'm just going to solve this last one and solve for X straight away. So when I do that, I have 36 over 44 is equal to X grams of carbon over my 82 grams of the whole substance. When I cross multiply this, I get 67.1 grams comes from carbon out of that 82 gram substance. Okay, this is by far and away the hardest one that people get confused over because it is a little bit different. We're kind of ignoring this. We're like using that, but not using that directly to solve for the equation. So I would definitely probably listen to this one again because this will definitely be seen on your test. All right, hopefully you have a basic understanding of how to calculate percent composition, and there are 3 different types of calculations that you will need to know, seen through examples 1, 2, and 3. So make sure you have a basic understanding of all these. Have a great evening.